Hello, my name is Taylor Ross. I'm an Aximmetry ambassador and the owner of Frustum Virtual in Los Angeles, California. In this tutorial, I'll be showing you how to set up your Aximmetry DE Composer with a custom Unreal project for tracked camera green screen live compositing. So the first thing we need to do is open Aximmetry Composer. The first thing you'll see is the Aximmetry Composer startup configuration. This is our video outputs page. I have my video output devices. I have 2 desktop monitors and my Blackmagic Decklink 8K Pro. I have my secondary monitor set to index 1 and my Blackmagic Decklink 8K Pro 2 set to index 2. To change any of the video indexing, you can use this arrow to drop down and select any of the index that you'd like to use. My Blackmagic Decklink 8K Pro 2 is my final pixel output. I'm currently outputting a UHD signal at 24 frames per second. To access these settings, I'll just select these 3 dots. This is where you can set the resolution and frame rate of any of these outputs. Currently, I'm doing a UHD at 24 frames per second. You just want to make sure that your frame rate matches the frame rate that your physical camera is currently recording at. I'll select OK. On the left-hand side, I'll navigate to Device Mapper and select it. The Device Mapper page has all of these different categories. In this tutorial, the main things that we're going to look at are video, camera tracking, and zoom encoder. If you'd like to set a preset for any of these categories, you can use this dropdown and then select any preset that you'd like to load when Aximmetry DE Composer starts. I'm not going to set any presets during this tutorial because I want to be able to show you how to set these up once Aximmetry is already running. In the category section, I will find camera tracking and select it. And then I will select Manage Devices. On the left-hand side of this window, we can scroll down, find the camera tracking section. This is where you'll find all of the different camera tracking solutions that are available with Aximmetry DE Composer. They have pretty much any tracking solution that you may be using. Just above camera tracking, there is a game section. You have OpenVR, which is HTC Vive, and then you have anti-latency, which is the anti-latency system. I'm using the anti-latency system for my camera tracking volume, so I will select it. With anti-latency selected, there's this Use Device property. You can use this dropdown to select the device that's currently connected to this computer. Once I plug the device directly into my computer with a long USB cable, it will populate this section. I've already set up this device previously, so you can see that it's labeled Camera 0. I will select this dash to clear the setting. Now I will take the long USB cable and plug it directly into my system. You can see that once the device is connected to my computer, it immediately populates this section. Now that my computer recognizes this device, I will select Camera 0. This is the device that's currently on my physical camera. With that selected, I can just select Apply and then OK. Now back in our categories, I will select Zoom Encoder, and then I will select Manage Devices. Again, on the left-hand side of this window, we can scroll down until we find Zoom Encoder. I'm using a Glassmark lens encoder, which uses the LowNet 2 server. I will select LowNet 2. I've already set up my LowNet 2 server. If this is the first time you're setting it up, you can select Add in the upper right-hand corner. I will quickly open my LowNet 2 server so you can see that my UDP port and Join Multicast group match. Once you input this information, you can just select OK. I'm just going to select Cancel because mine is already set up. Finally, you can select Apply and OK. We'll navigate back to the video outputs at the top. Now that all my devices are mapped and all of my video outputs are correct, I will just go ahead and select Apply and Start. Once Aximmetry starts, the first thing that you'll see is a blank sequence editor. The first thing I will do is navigate to Edit, Preferences. On the left-hand side of our preferences, we will find Rendering. This is where you can set the frame size and frame rate that Aximmetry will be rendering. Since my physical camera is recording at 24 frames per second, I will make sure that Aximmetry is rendering at the same frame rate. Just make sure that the frame rate in Aximmetry matches the frame rate of your physical camera. For this frame size setting, I have it set to 1920 by 1080. You can experiment with any of these frame size settings. Just keep in mind that the higher you set this, the more it will impact your performance. You can monitor the performance of your system in the bottom right-hand corner under Processor Load. Just make sure that you're not setting this too high because it will impact the performance overall. For this tutorial, I will leave this setting at 1920 by 1080, and then for my frame rate, I'm going to set this to 24 frames per second. Once I'm happy with those settings, I'll go ahead and select Apply and OK. Now we need to create a new compound. I'll navigate to the New tab, and then I'll select Compound or Control-N on the keyboard. On the left-hand side under Projects, we will find Common Studio, and then we will find the camera folder and open it. Select the TrackCam Unreal folder. For this tutorial, I'm going to use the TrackCam Unreal 3 cam. I'll click and drag this directly into my compound. Once that's added to the compound, we need to add the Unreal project that was cooked in the last tutorial. I'll just open my file browser. By default, this is in Documents, Unreal Projects. We're looking for Aximmetry Tracked Camera 01 with a 5.3 at the end. This is the project that we created in the previous tutorial. I will open this folder, find the Unreal project, Axi Tracked Cam 01, and then I will click and drag this directly into my compound. You'll see that this is loading in the bottom right-hand corner. Once this Unreal project loads, you will see that there are pins that correspond to the pins on our TrackCam Unreal. I will line this up and then click and drag between each pin with the corresponding name. Once all of these pins are connected, on the right-hand side of our Unreal project, we will click and drag from Out to Rendered and from BMask to BMask. Now on the right-hand side of our TrackCam Unreal 3 cam, we will click and drag from Preview to the output bar on the right, and then from Out to the output bar on the right. Once this is connected, we can just select OK. In my Preview 1 and 2, you can see that it says Device Not Found. This is because we haven't set up any of our inputs. When we added the TrackCam Unreal 3 cam to the compound, it added some tabs at the top. We have Flow, Camera, and Input. In order to set up our inputs, we're going to navigate to the Cameras tab. In the Select Camera square, we will make sure that Camera 1 is selected. Cam 1, Cam 2, and Cam 3 correspond to the Inputs tab. Input 1, Input 2, and Input 3. So in our Cameras tab, with Camera 1 selected, we will be affecting Input 1. With Cam 1 selected in our Cameras tab, I will select this Input 1 square. This will open the settings for Input 1 on the right-hand side. The first settings that we need to set up are Camera Device, Camera Mode, Tracking Device, Calibration Profile, and Zoom Device. I will select this drop-down next to Camera Device. This is my video input. I know that I'm sending in my video input through Blackmagic Decklink 8K Pro 1, so I will select it. I can select these three dots next to Camera Mode. This will allow me to set the resolution and frame rate. I know that my camera is sending a 1080 at 24 frames per second. You can also leave this set to auto. But since I know that my camera is sending a 1080 signal at 24 frames per second, I will just specify that here, and then I will select OK. Now I will set up my tracking device. I'll use this drop-down. I will find my Game Anti-Latency Camera 0 and select it. After that, I will use these three dots to select my calibration profile. In the Camera Calibrator and Basic Calibrator tutorials, I show you how to create a calibration profile. I will just find the lens that's currently on my camera and select it, and then I will select OK. Finally, I will assign my zoom device. I'll use this drop-down, and then I will select my Low-Net 2. This is my Glassmark lens encoder, which I will be using for focus. I won't be covering all of the Input 1 settings in this tutorial. I will just be covering the basic input settings that you need to use to get this up and running. The next setting that I'm going to talk about is manual lens. You can use this setting if you didn't create a calibration profile. I will just turn this on to show you what it does. In my Preview 1 and 2, you can see that it looks like we're quite zoomed out. In Monitor 1, I can select Studio to see a better view of this. Now I will reselect the Input 1 square to see the input settings. So once we have manual lens turned on, there's a manual zoom and manual focus. You can click and drag in these settings to adjust these values. This allows you to manually set the zoom and focus to match the zoom and focus of your physical lens. In order to get a more reliable result, you should go through the calibration process and create a calibration profile. But it is possible to get this to match. It just takes a lot more time and you kind of have to eyeball it. Since I have a calibration profile and I won't be using these manual lens settings, with this manual zoom setting selected, I will hit Ctrl Q on my keyboard to reset it, and then I can turn off this manual lens setting. With the manual lens setting turned off and my calibration profile enabled, you can see in Preview 1 and 2 that I have a much more accurate representation of my focal length. Below our manual settings, we have external lens data, and then below this, we have camera delay. Camera delay is used if the camera feed is coming in faster than the camera tracking data. Most of the time I will leave this setting to 0 because the camera feed is actually coming in slower than the camera tracking data. This is because the camera feed takes a lot longer to process than the actual camera tracking data. Next, we have all of our sync options. The main thing I'm going to cover here is our auto detect functions. So we have detect tracking delay and detect zoom delay. We also have detect target color, and then tracking delay and zoom delay. These detect functions will allow me to auto-detect the tracking delay and zoom delay. I will quickly show you how these detect functions work. I have a photo of a red circle on my phone that I will place on the floor. Because my detect target color is set to red, I will be using a red circle. I've tilted my camera down to be looking at the floor. I will turn on detect tracking delay. Aximmetry is now prompting me to place a distinct vibrant red flat object in front of the camera. Once Aximmetry recognizes this red object, it will update to say rotate the camera left and right. It will also place an X on the red object that it is currently tracking. I can just pan my camera left and right. Aximmetry will then say delay found and set. Once the tracking delay is found and set, it will update my tracking delay property with this value. I don't have a zoom lens, but you can also use the detect zoom delay to populate this zoom delay setting. Next, we have tracking dejitter. This setting is used to remove any jitter that you might see when your camera is still. So if you're not moving your camera and you see that your tracking is kind of jumping around, you can use the tracking dejitter setting to try and remove some of this jitter. Now that I've covered all the basic input 1 settings, I'll navigate to this green studio square. You're also going to want to select Studio in the Monitor 1 square. When you select Studio under Monitor 1, it will auto-select this green studio square. With this studio selected, you will see the studio settings on the right-hand side. Studio allows us to calibrate the physical and virtual worlds. We have front wall, left wall, right wall, back wall, ceiling, and floor. These correspond to the physical walls of your studio space. Below that, we have green front left, green front right, green left, green right, green top, and green floor. All of the green settings correspond to the green surfaces of your green screen studio. All of these values will be input in meters. In order to get accurate measurements, we need to know where our origin is. To set the origin, we will select this orange origin square. I will tilt my camera down so that I can see this ArUco marker that I have placed on the floor. There will be a link in the description to this ArUco marker if you need it. I've printed this out and placed it on my floor. With the ArUco marker in the view of my camera and this orange origin square selected, I will navigate to detect origin on the right-hand side. I will select trigger. The origin will snap into place and be set at the center of this ArUco marker. You can see this in my preview 1 and 2. With the origin set, I can take measurements from the center of the ArUco marker to all of the walls of my studio. I will go ahead and tilt my camera back up so that we can see all of the walls of my studio. I've already taken all of these measurements because I use this space quite often. I have the green studio square selected, so I will just start with my front wall. This is the wall that will be directly in front of my camera. The front wall is 2.444 meters from the center of the ArUco marker. My left wall is 1.96 meters. My right wall is 1.63 meters. For the back wall, I won't be adjusting this setting because we will never be looking backwards for this tutorial. For your own studio space, you can just measure from the center of the ArUco marker to the back wall. For the ceiling, I'll input 2.32 meters. For the floor, I will just leave this value at 0, since the ArUco marker was placed on the floor. Now we will adjust all of the green settings. Green front left and green front right correspond to the green of my front wall. I will quickly increase the green front left value to show you what I'm talking about. You can see that this just moves the green front edge of my front wall. Now I will input my green values. Green front left is 0.61. Green front right is 0.53. The green left and green right settings are used if you have a second green wall in your studio. I don't have a second green wall in my studio, but I will increase this value so that you can see what it does. You can see that it's extending a green surface on my left wall. I'll go ahead and set this back to 0. The green right setting will do the same thing, but on the right side. The green top setting will adjust the height of the green screen itself. I will bring this down so that you can see what I'm talking about. Just remember that anything that is inside of this green volume will be composited in your final pixel image. Finally, we have green floor. I will set this to 1.15 meters. The last thing I want to cover in these settings is this new function called Mask Edge Fade. To show you what this does, I need to go to my final view in Monitor 1, go back to my studio settings. As I adjust this Mask Edge Fade, it will feather the mask between our studio and our green screen footage. This is a pretty cool new function that will get rid of that hard line. I will go back and select Studio in Monitor 1. That covers the basics of all of the studio settings that you will need to set up your actual space. Now we will set up our keyer settings. Select Keyed in the Monitor 1 panel. This will automatically select the green square labeled Keyer 1. With the green Keyer 1 square selected, you will see the settings for our keyer on the right-hand side. You can see that my green screen is already being keyed out. This is because in monitor mode, we're set to final. If I change this monitor mode to input, we will see the live camera feed coming from our camera. With the monitor mode set to input, we can select the background color of our green screen, find background color on the right-hand side in our settings, and select this green square. Now in the lower left-hand corner, we will click and drag this eyedropper onto the green color of our green screen. When we let go, it will select this color. Now under monitor mode, we will change the monitor mode from input to matte. This will change our preview 1 and 2 to a black and white image. In this black and white image, the black is what will go away and the white is what will stay. I can now adjust my high cut and low cut values. The low cut will be affecting the black sections of our image, and the high cut will be affecting the white sections of our image. The green color that I've selected is not giving me a very good key. I'm going to reselect my color. This time I will hold Shift on my keyboard to get a larger selection of green. Now I can just select OK, change my monitor mode back to matte, and then I will readjust my high and low cut settings. I'm not going to worry too much about getting a perfect key for this tutorial. You should get the idea of how this works. Once we're done setting up the Advanced B key, we can just go up here to monitor mode and select final. There's a lot of other keyer settings that you can manipulate in this section. Feel free to experiment with all of these settings on your own. Now in monitor 1, I will select final. This will show me the final composited image with my Unreal background. To fix the focus, I need to zero out my lens encoder. Now I will select this orange square labeled scene. This will show me all of the scene settings on the right-hand side. This lens distortion setting will turn on and off the lens distortion for my camera calibration. With lens distortion on, I have this black edge around the edge of my frame. We can use the edge expand setting to fix this. In the scene settings, I will set my edge expand to 0.04. This will fix the gap created by lens distortion. Now in our scene settings, we have a use billboard function. I'll go ahead and turn this on, and I will switch to final in monitor 1. The use billboard function puts our live camera feed on a billboard in our virtual scene. This allows us to light our talent with the lighting from the Unreal scene. I can select billboard 1A to see the settings for this billboard. On billboard 1A, there's a little light bulb. We can turn this on to see the position of the billboard in our scene. By default, this billboard is placed at the 0 point of our origin. We need to place the billboard at the proper distance from our camera. To do this, we can turn on the lock to camera function in our billboard 1A settings. Turning on this lock to camera function will place the billboard at a specific distance. You can adjust these specific distances using the locked distance, locked width, locked height, locked offset X and Y. It's important to remember when using a billboard that everything is one-to-one between the virtual and physical worlds. So you want to take a distance measurement from your camera to the billboard. I usually use the lock to distance function to just place the billboard in front of my camera, and then I will turn the lock to camera function off and use these transform values to place the billboard just in front of the feet of my talent. You will just have to experiment with these settings to find out what works best for your scene. Just remember that when using a billboard, all of these distances are one-to-one between the virtual and physical world. There are a lot of other billboard settings that you can adjust. You will just have to test and experiment with all of these settings to see what works best for your scene. You can also set up a tracking device for your billboard. So if your talent is wearing a tracker, the billboard will move with the talent. The next main setting that I want to showcase in this tutorial is this lit function. Turning this on will use the Unreal Engine lighting to light the billboard. You can also turn on and off cast shadow, render to depth, inverse tone map. Inverse tone map will affect the color correction, alpha correction for brightness. There's ray traced reflections, meter opacity, and tracking delay. Tracking delay will be the tracking delay for the device that is tracking the billboard. I'm not going too in depth on most of these settings. In future tutorials, I will go over most of these settings in depth. For this tutorial, I am just covering the basics. Next, we will go over a few more of these nodes on the left-hand side. I'll select Adjuster 1. This will give you some color correction settings for this input. Feel free to experiment with all of these color correction settings. I will quickly adjust the brightness just to show you one of the settings. Now I'll select my Scene tab. In the Scene tab, we also have some transform functions. I can adjust the base cam transform to move my entire scene. If we are using a billboard and moving forward or back, we will also need to adjust the position of the billboard. I will just quickly show you what I mean. As I adjust the base cam transform of my scene to move further away from my billboard, You can see that my billboard is being cropped through the floor. This is because the billboard isn't moving with the scene. When we move the scene, we will need to adjust the position of the billboard. As I mentioned before, the distances are 1-to-1 between the virtual and physical world. So if I move my scene, I will also need to move my billboard. If you've moved your scene and now your billboard looks odd, this is how you would fix that. Just remember that when you move your scene, you need to update the placement of your billboard. The last thing I'm going to cover in this tutorial is how to do a virtual camera move with a tracked camera. I will navigate to the Cameras tab at the top. In the camera mode settings, you have this little mouse, as well as this little camera. The camera is the final rendered view. To the right of this, you have play, pause, and stop. If I select the mouse, it will take me into free mode. This will be a 3D view of our scene from a different view than our actual camera. This will give you the ability to fly around your scene similar to the way that you would fly around your Unreal Engine scene. In camera mode, I will select the camera. Now in edit camera path, we have an A and B position. Similar to what I've showed you in the virtual camera and mixed camera tutorials, you have the ability to move around the scene. With A selected, I can reposition my camera, and then I can select play. Now I've created a camera path between A and B. In preview 1 and 2, you can see that I'm now moving between those A and B positions. While this virtual camera movement is happening, I can also pan and tilt my camera. This will use the camera tracking data in real time. So as I pan my camera left and right, you can see that it's updating in preview 1 and 2. In another tutorial, I will cover this more in depth. I just wanted to give you a quick bonus of something you might not have known you could do. I'll navigate back to my flow tab. With everything we've covered in this tutorial, you should be up and running for tracked camera green screen live compositing using Aximmetry DE. From here, you'll want to make sure that you've saved this Aximmetry project. Just come up here to File, Save As. Once your project is saved, you can just close Aximmetry DE Composer. Hopefully this video was helpful in getting you started with a custom Unreal project and tracked camera green screen live compositing using Aximmetry DE. Be sure to like and subscribe for more videos, and thanks for watching.